Hello, everyone. So, this is a quick one to guide you through some of the things you need to revise getting into the exams. I know the video has come a little bit late, but kindly bear with me. These are things we probably covered in class. So, I'm going to start off with functions and then we are going to end up with the object oriented programming, which is very simple. So, specifically in the handout, we have this on page 48. And remember earlier on when we started our whole computer programming journey, we looked at this TV remote scenario and we said these buttons, as you can see over here, when pressed or when clicked, give the TV set some kind of functionality. So we created every button over here, like, okay, there's a function of its own, there's a function of its own, and stuff like that. Now, when we came into VS Code and we are writing our code, we saw this, the main function. And remember what I said was that the main function was almost behaving like this power button. So this is more or less the entry point to the program, in the sense that the power button is more or less the entry point into the TV system of its operation. So when I click on it, and assuming power is connected and everything is okay, it opens up the TV for me, or it switches it on. And when I press it again, all things being equal, it turns it off. And that's exactly what we saw with this particular main function. We saw that whatever piece of logic we write inside of this main function, when we run this code, is almost like pressing that power button, it opens it up. So for instance, when I do a cout and then inside of this, say Ken, bring my semicolon over here, and then when I click on this to execute or run this code, certainly we are going to see this output show up over here. So these are things we know already. Now we are going to extend this conversation to writing functions, and what we have over here is this a more technical definition of what a function is. So we are seeing a function in C++ is a block of organized and reusable code. They are defined using the return type. So we are going to see all these, followed by the function name and a parenthesis containing optional parameters. Functions can return data using the return statement. If no value is returned, the default is none, or they default to none. Now this is a general syntax of how a function should look like. So typically we'll have the return type. In the case of the main function, the return type is always an integer. Okay, and one of the technical reasons is that if you take a look at this power button, okay, you see that the power button is like the symbol is a 0 and a 1. Okay, a 0 and a 1. So it is a whole number. It is either on or off, and that's exactly what this main function is behaving. It is either a 0 or a 1. It is either on or off, and you can see that we have returned 0 over here, but then if it returns 1, then it means everything over here is looking good. That's just how you need to look at it. So this is the general structure of a function, and it is such that, let me clear this, it is such that it will have a return type, then the name of the function, followed by a parenthesis, and then whatever thing we want the function to perform, or the computer logic. So in here, let me just zoom out a little bit. We are saying that the general syntax is we have the return type, we have the function name, the parenthesis, and then whatever code we want to execute will be in there. And there's a bit of explanation over here. So let's look at what we have over here. Now, in order to write a function, we'll go outside of the main function. Okay, and then we'll write the function. So I'm going to use the return type void. Now, we normally use, for instance, if we expect the output of the function to be an integer, we use the int return type or the data type. But in some cases we would want to use void, because void gives us the laxity. Okay, maybe we don't know at the end of the day what the return type is going to be, so we can use void, which will tell the system that, well, create some memory allocation or an empty container, as I always say, and then some value will be sent in there, but we don't know the data type yet. And let me call this greet function. So this is the name of the function. Then I bring in a parenthesis. Now inside of this parenthesis, we can have some things in there we call parameters. We are going to come to that later on, but then I'll open this up this way. And now what I have over here is my function definition or declaration. So I have the return type, the name of the function, and then a parenthesis over here. So far this function does not do anything, but then let me just write some code over here. So I'm going to do a cout, and I'm going to say hello Ken. So what I've ended up doing from line 4 to line 6, okay, this block of code is that, well, I have a function. The name of the function is greet function. The return type is void. And then inside of that function, I have this block of code, which basically will output hello Ken over here. All right. Now, when I run this, well, nothing seems to happen, okay? Or at least we don't see anything over here, even though we have cout hello Ken. Well, that's almost like we assuming nothing has happened to our TV yet. Our TV is off, and all of a sudden we start, for instance, clicking on this button over here, the volume up or the volume plus button. We are not going to have the volume increased. Okay, the volume is only going to increase if, first of all, this power button is clicked, and then any other one that we click thereafter is going to work. So clearly over here, the main function, inside of the main function, there's nothing. And remember, the main function is more or less the entry point to our program. So in order to make this work, we need to call the function. We need to call the function, or in other words, we need to invoke the function. Now, in calling the function, it is very simple. We come into the main function, and then we write the name of the function and bring in a parenthesis this way. So when we do it this way, this simply means that we have called the function inside of the main function. So over here, it's like we have pressed the power button, and after that, we are pressing the volume button or anything within that space. So over here, what it also means is, once this main function is called, I want this greet function executed. And when this greet function is executed, you could see that the logic in there is hello Ken. So now when I run this, we clearly have hello Ken showing up over here. All right. Now let me end line this way and then do a number of things. So now I have hello Ken. Now I can call this function again. So when I call this function again, clearly on line 9, I've called the function for the first time, and then on line 10, I'm calling it for the second time. So now when I run this, we see that this is exactly what you get from line 9, which is saying executes the greet function, and then the logic inside of the greet function is hello Ken. So that's what we see from line 9. And then this is definitely what we see from line 10, because we are executing that function again. So clearly you could see that we are coming back to the definition we had over here, that a function is a block of reusable code. It is a block of code, as you can clearly see over here, and it is reusable. So we are calling this function as many times as we want. But functions are not just like as we see it this way. There's more to this than just greeting ourselves this way. So that'll bring us to an important concept we have over here. So in here you could see that I have the example over here. We have the void, the return type, and the name of the function over here in the handout is greet. And inside of greet we have this logic over here, and over here you could see that there's a comment which shows that we are calling the function over here. So the handout practically tells you everything that's happening over here. And let me quickly look at some few things over here. So over here, a function may have parameters. Okay, so the question is, what exactly is a parameter? And if you come back to the notes over here, let me see. Very good. We are saying that for the function that we are talking about in C++, they are defined using the return type or the return data type, followed by the function name, as you can see over here. And a parenthesis containing optional parameters. So this parenthesis, as we have over here, it can contain some parameters, okay? So you're going to see exactly what these parameters are. So now, let's assume anytime you call this function, it is going to give me hello Ken, okay? But what about, okay, I want to call it, or I want to have a function that will be a little bit dynamic. Dynamic in a sense that if I am Ken, it should greet me and say hello Ken. If it is Kojo who is calling the function should be able to greet and dynamically say hello Kojo, something like that. So in order to get that, we need to pass in a parameter over here. So what is this parameter? A parameter is nothing but a variable. So the concept of variable is also working out over here. So that's empty container. So we want to pass something like a name over here. But then of course we know how we do this. We always have to make sure that we have the return type. So this is a data type, and we are telling the system that, well, this function will have a parameter, and that parameter is a string. All right. Now something interesting is going to happen over here. When I have it this way, remember this is optional, okay? When we didn't bring it, the function was working, but we want it to be a little bit dynamic. Now when I run it this way, now we have a problem. And you can see that the problem is coming from line 9. And if you can see the error code over here, it says too few arguments to function. Void greet function, whatever, let's see. Okay. So clearly it is telling us that, well, there are too few arguments, okay? So the big question is, what is an argument? Now, the argument is the value we have to send, or we have to input over here when the function is being called. Now, as soon as we have a parameter, it is almost like doing this. If we have string name is equal to, then there's a big problem. We have told the system that, well, there's going to be a string, or there's going to be an empty container with a label name, and it's going to contain some strange values. And then we left it this way, the system is going to get confused. The system expects to see the Kojo or whatever value you want to pass in there. All right. Now, in order this to happen, we just have to come in here and then pass in Kojo this way. So when I do this, this now becomes the argument, and this argument is going to be sent into the container with a label name, just as we have on line 7. Okay. So let me just comment this one out so that we get our way through. So now when I save this, now what I have over here with this argument is being sent into this empty container parameter, and at the end of the day, it's going to look like what we have on line 7. So now when I execute this code, we are still getting hello Ken, and we are getting hello Ken because, well, we have practically sent this over here. But then when we look at line 5, the logic we are trying to execute is whenever this function is called, we are saying hello Ken. Name is not being used yet, and that's exactly what we see over here. When this function is called, we are saying hello Ken. So now here's the catch. The catch is, now as long as we have a parameter, which is a variable over here, we need to provide an argument for it, whether we are going to use it or not. Okay. So once we have a parameter, we need to provide an argument for it, whether we are using it or not. So if we don't provide an argument, which is the data, then we have that problem as we saw before. All right, we don't want to have that. But it is also not just for the fun of it that we would want to provide a parameter and an argument, and then we don't end up using it. Okay. So over here, instead of doing this, I'm going to say hello, and then I can use the name over here. So clearly this name Kojo will be sent into this parameter variable, and then the logic I want to execute is I want to do a console out and then hello, and then I'll attach the name to it. So now when I run this code, everything looks good. Now we have hello Kojo. This one is making sense. So let's say somebody in the class, I don't know, and maybe the person is Amma. So Amma calls this function. Now this function is a little bit dynamic. When Amma runs this, of course, we are going to see hello Kojo, because the function is called on line 9. And when the function is called, it's was provided with the argument kojo, which is the value that will be sent into this how do you call it, parameter. And then within this block we are saying that hello whatever name that was sent, and in the case of the first one it was kojo, in the case of the second one it was ama. So you can see that we just have one code, but then it is very dynamic and we are applying it in a very interesting way. Now it is the same as we have over here with this buttons as we see. So for instance, the first time was something like hello kojo. Okay, so hello kojo was like using this plus button, and maybe hello ama was like using this minus button over here. Okay, so depending on the value we put inside of the function, I just want you to think about it in a very figurative way. Depending on the value we put in the function, as in the argument we put, it is going to execute based on that particular thing. So if it was plus, it is going to increase it. If it was minus, it is going to decrease it. And it is the same work of the function. So this one is looking good. Now, there are some few things I would also want to point out. Now, we can have a number of these. So let's say I do a comma and I do an int age. So over here, the function is expecting, let me just comment this one out. So over here, the function is expecting 2 arguments, okay, because we have 2 parameters over here. If the parameters are 10, that means we expect 10 arguments. It's as simple as that. So clearly now, let me collapse this. Now when I run this code, we have a problem. And the problem is also coming from line 9, okay? It says too few arguments because it had 2 parameters over here, but then we are providing just 1, okay? And if I get rid of this, it is even making it worse because we have 2 parameters, but then on line now, currently as we have it, I've deleted everything and we have 0 arguments over here. Let me just clear this one off and this as well. So clearly we need to make this work. So what I'm going to do is, okay, I'm going to have Ken over here, and then I'll do a comma and then use my football H12. So currently what I have is, okay, it was expecting 2 how do you call it, parameters, and then I've provided 2 arguments over here. So now when I run this, well, I'm getting hello Ken. Nothing 12 is showing, and that's simply because I just have to provide it once there's a provision over here to add something like that. But now let's look at an interesting one. Let me change this one to a strange, and then let me call this school, and let me do ATU over here. Now the point I want to make over here is these how do you call it, these parameters are positional, okay? This is what I mean. They are positional, okay? In a sense that the first argument will be sent to the first parameter over here. And the second argument will be sent to the second parameter. So let me just show you that. So let me say hello Kenneth, or hello whatever name that is provided. And let me do this. Welcome to, I just want to have it properly formatted. Welcome to, and then I'll have school over here. So it is going to be hello whatever name that's provided, okay, in this case Ken, and then we have welcome to, then the school that will be provided. So this one is going to read hello Ken, welcome to ATU. So now when I run this, that's exactly what we have. Hello Ken, welcome to ATU. Okay, all right, let me just leave a space over here so that it looks properly formatted. So let me run it once again. We have hello Ken, welcome to ATU. Okay, so everything looks good. Now if I bring ATU first and then I provide Ken over here, now C++ does not know the difference between ATU and Ken. You have just provided it. So the point I'm making here is Sorry. The point I'm making here is these arguments and parameters are positional in a sense that the first one over here will be sent to the first variable over here, and the second value over here will be sent to the second variable over here. So when I run this, because of the positional nature of it, it's now telling me hello ATU, welcome to Ken, which is not exactly what we want. Okay, so we need to be very careful. If name is first, we need to make sure that name is coming first over here, followed by whatever thing we want to appear next. So now when I run it this way, everything looks good. All right. Now the last thing I would want to touch on when it comes to functions before we get to writing proper functions is, because this one we are just covering the basics, the fundamentals, is the fact that okay, so with these how do you call it, parameters, we can have a default value for one of them. So for instance, maybe for school, I can set the default value for school to ATU. So when I set the default value to ATU, what it means is I can decide not to provide one over here. Okay, so I'm just providing Ken or a value for name. And because I have a default for school over here, it will automatically kick in. So now when I run this, we are still getting hello Ken, welcome to ATU. However, if I provide, for instance, a value or an argument, so I'm going to say UCC, then this one is going to overwrite the default value that was provided. So now when I run this, we are going to see hello Ken, welcome to UCC. But if I don't provide anything for school, then we are going to have hello Ken, welcome to the value that has been provided as the default value. So this is very important. However, if we leave it blank this way, then we are going to have a problem. And the problem is like that. Well, then what becomes of name? So when I run it this way, then there's a problem. Okay. Now the unfortunate thing is we cannot do this. Okay. We cannot have it this way. I mean, you cannot have it our way all the time. Okay. So we have a default value over here. Okay. Oh well. Okay. So we can do it this way. In other programming languages, this is not going to work. So we are saying that okay, here default values have been provided for everything. However, if I'm to explicitly provide one over here, now the first name is going to be the name is going to be how do you call it, overwritten, and now we have Bruni over here, and then ATU is the last one, so it takes care of that. And then if I'm to do let's say UDS, now everything will be overwritten. Okay, the default values will just be cleared off, and then we have whatever thing that was provided as the argument over here. So this is just the introduction to functions. Now let's look at more practical examples of functions. So getting to the more practical examples of functions, let's say you want a function that will take up two numbers and then it will return the sum. Okay, so the words I'm using over here is a function that takes two numbers and returns the sum, okay, of those numbers. So this is an interesting one, a function that takes two numbers and returns the sum. But then I want you to pay attention to the words I'm using over here. There's a return over here, but then we'll come back to that later. So based on our understanding of computer programming, okay, so a function that takes two numbers. So the first question I'll probably be asking in classes, okay, so how many parameters are we going to work with? Remember, the parameters are the variables we pass in over there inside of the function definition. And because the function is going to take two numbers, we can say that okay, then the function is going to have two parameters. So you can say two params, okay? And now the second question is, how many arguments will the function take or have when it is being called? Well, it is also going to have two arguments, okay? So let's call this two args. So now let me clear this, and now let's work our way through. So we know that these are the things that we need. Now the question is, or the next question is, okay, what is going to be the return type? because there's some additions and subtractions of numbers, or we are doing some arithmetic operation, and we know that we are expecting a number at the end of the day, we should be thinking as such. So okay, so the data type or the return type, we can look at it from an int perspective or a float perspective or a double perspective. It cannot be a string, cannot be a char. So these are things we already know. All right, then the next question is, okay, what is going to be a suitable function name? Now a suitable function name should, I mean, we should take inspiration from what we learned when we were dealing with variable names, because the function name should of course be descriptive and stuff like that. So for instance, the greet function was doing exactly what that function does. So we would also want to have a function name over here. So now that we know all this, now let's actually write the function. So I'm going to say, okay, I'm going to use a float, and I'm going to say add function. I'll bring in the parentheses, and then I'll open and close it up this way. So I know this is how my function is going to look like. I've selected a suitable return type, and I've also proposed a suitable name which is very descriptive. Anybody who sees this function knows that, okay, well, something is being added one way or the other. Now this is where I need to provide the arguments, or sorry, the parameters. So I'm going to say float, and I'm going to say maybe something more descriptive. So I'm going to say first number, comma, then I'll do float, then I'll say second number. Very descriptive variable names or parameter names as we have over here. Now inside of this, I can also declare another float, okay, and then I'm going to say results is going to be equal to the first number plus the second number. Now as far as this logic is concerned, clearly these are things we've dealt with over and over again. For instance, when we're dealing with the how do you call it, the arithmetic operations, except that this time around we are only using functions to call them, okay, or we are packaging it in a function. Then I can now do, look at this, I'm going to do a cout, and then I'm going to say sum is equal to, and then I'll just pass in results over here, and let me just end line for some other things I'll be doing. So now when I do it this way, everything is looking good. The logic, the main logic is what we have in the function body, okay, and inside of the function body we are saying that, okay, we have another empty container, and that empty container is going to have first number, and then we are going to add second number to it, and we are going to call that result. And when this function is called, eventually given the necessary numbers or the arguments, it is going to do the arithmetic summation over here, and then it's going to just console out sum and the results over there. So now let's call this function, and in calling this function we have the add function over here, and then because we have two arguments, let's pass in two parameters. So we do, for instance, 2 and 3. Now when we do 2 and 3 and we run this code, clearly we see that sum is equal to 5. This one is making sense. But the beauty about this is, okay, I can call this add function a number of times, okay. I do -10, 5. Then I call this add function again, and I'm going to do 100, 700. I can call it as many times as I want because this is a block of reusable code. And now when I run this, clearly you see that for the first one I have sum is equal to 5 because clearly 2 plus 3 is 5. Then the second one I have sum is equal to -5 because indeed -10 plus 5 is going to be -5. And then with the last one we have sum is equal to 800 because indeed 100 plus 700, we are getting 800 over here. So clearly our function is working, our parameters and our arguments are looking good, and everything is fine over here. So we can extend this conversation over and over again. Now you also recall I said something about this return, okay. So when you read the notes, we are going to see that we have something over here. Let me just show you. Very good. So we are saying that they are defined using the return type, okay, followed by the parentheses, blah blah blah. Now functions can return data using the return statement, and if no value is returned, the default is none. So over here we are just using cout, okay? But then let me just show you something interesting. So in here, I can do return, and I'll say results this way. I'll just leave it this way. Return results. Return results. Now, when I do return results, let me just also clear these ones so that we concentrate on just one and analyze it very well. When I say return results and I call this add function and I pass in these two, and when I run this, we don't see anything over here, okay? Now, it doesn't mean something bad has happened, but it's because we are using the return. Now, remember earlier what I told you about cout. Cout gives us the functionality of outputting things onto the stream or onto our console for us. Now, as far as this logic is concerned, we haven't contracted cout in any way, but then the value is being returned. Now, in order to see this, we can now come and do a cout over here. So now I'm doing cout, then whatever logic inside of the add function which is being returned, I want it to be consoled out. So now when I run this, we are getting 5 over here. If I'm to call this function again and say 20 and then 300, we are expecting to see 320. So that's exactly what we see over here. So now the big question is, okay, why do we have to do this return over here and not just cout? Okay, because cout makes it very simple. We don't have to come and do anything over here again. Well, most of the time you would need return, okay, because return helps us and we can do a lot of other things over here, and I'll just show you with a very simple example. So the point is, whatever application that you write, okay, not all applications are going to have the benefit of the console, okay. Not all applications written in C++ will have the benefit of the console to be having cout show up this way. In some instances, you would want to have the value stored somewhere and then you use it in another way. So let me just show you this. Let's call this let's have a variable. Let me say float x is going to be equal to this. When I say float x is equal to this, I'm trying to say that, okay, when I execute this add function and whatever thing is being saved or being added over here, save it in a variable called x, and now I can now do a cout of x. So we are going to get same results anyway, but then this is very helpful in a sense that, okay, now let's look at the bigger picture. The bigger picture is, let's have this as income, okay. So let's say your income is 20 and 30, and let's have another float, and let's call this taxes. And the taxes is also probably going to accumulate a number of taxes, okay. So maybe there's e-levy, which is maybe 5 cedis, and maybe there's income tax, which is maybe 10 cedis. So your income, let's say this is your basic salary and these are some allowances, and for the taxes you are paying, it is going to sum everything up, okay. So this is your let's say your e-levy, and then this is your income tax. So everything has been summed up. Now at the end of the day, what you get is your net salary, okay. So I'm going to have this float and I'm going to say net underscore salary, and your net salary is going to be your income minus your taxes, okay, or your gross minus your taxes, depending on how technical you want to become. Now I can do a cout and now see my net salary. So now let's just do the calculation manually over here and see if you are going to get same output over here. So over here, when we add these two, we are going to get a 50 over here. Then in here, when we add this and this, we are going to get a 15. And certainly when we subtract 50 from 15, we should expect a 35 for the net salary. So now when we run this, that's exactly what we get over here. So this is making a lot more sense, okay. Why we would want to use the return? Because when we use cout, what it basically means is, as soon as the function is called, console out something. No, this time around we want to have it saved somewhere, and that's the purpose, or that's one of the main reasons we would want to use the return type over here. Okay, so this is looking good. Now please, everything I've said over here, you have it in the handout, so clearly read through everything you see over here, and then everything is going to make sense. Okay, so we have the parameters over here. So like I said, there's a variable in the function definition. It is used to receive and store data into the function when it is called. The parameter are placeholders, blah blah blah. So you have them over here, and we have examples over here. So over here I used the int, and the function name is add, and this is the first parameter, this is the second parameter, so a and b, and then right away we are saying return a plus b. Okay, and then when the function is called, we are using cout over here, and we call the add function, and we are expecting to see an output of 10. So like I always say, try and type this code you have in the handout, and then you practice alongside with some other examples that you may also come up with. Then over here you could see that I'm talking about the default parameters. Okay, so over here there's a strange name, and we have a default of guest over here. So when Alice is called, or when we put in Alice, it now says we are calling with Alice. Okay, but then when we don't provide anything, then we are calling with the default which was provided as guest over here. So clearly these are examples I spoke about. Now we also have instances where we can have multiple parameters. Okay, now these are multiple parameters. Don't worry, you can type this code in there, but over here sometimes it is very difficult to know exactly how many parameters a user may want to have. Okay, so if it is 2 parameters, then we know we are providing 2 arguments. But what if it is 10? What if the next day it is 20? The next day it is 500? It can be anything. So let me just give you a typical example of how things might look, especially with this particular one. Okay, so let's say you go to the shopping mall, or maybe an online store. Okay, so we have an online store, and in the online store we have the shopping cart. Okay, so we have the shopping cart, and in the shopping cart, just look at the bigger picture. The shopping cart is going to be like one variable. Okay, so maybe float cart, okay, or float shopping cart, and that shopping cart should contain maybe the number of items you have clicked, their prices. So maybe you bought first day you bought, let's say, 5 items. Okay, and for the 5 items, let's just assume maybe the first one cost 10 cedis, the second one 20 cedis, the third one 30, 40, and then the final one was 50. So you have these items over here. So this is let's say you could use shopping cart, same website. Amma goes in there and Amma buys 3 items. So Amma shopping cart looks like 300 for the first item, 10 cedis for the second item, and then 40 cedis for the third item. And maybe so there's Amma. And finally, maybe Ya goes on the shopping cart, and Ya just buys just one item, 10 cedis. So this is Ya. Now what this basically means is, if you are writing the code for this application, you should be thinking ahead of, okay, what are the possible issues or the possible things the user will be thinking about. Now if I make the system such that it is going to accept as we have over here 5 parameters, then when Amma just adds 1, when the arguments are being put in there, then there's going to be a problem, because it is going to expect 5, but then 1 was given. I mean, the case of Amma was also just looking at 3. Okay, so we can have those complicated issues like that. And let me just do it this way. So let's say we have float, let's call this shopping underscore cart. Okay, so this is a very descriptive function name for our function. Now if I put, let's say, float item 1, float item 2, float item 3, up to 5 for Kojo, then Amma will have a problem. Now, somebody can say, okay, then for each of the items, okay, let me just do this so that everybody has a sense of whatever thing is happening. So float item 2, then I can say float item 3, and I can go on and on and on, okay. And somebody can say that, okay, in order not to create confusion, because whenever this shopping cart function is being called, okay, then something needs to be provided for item 1, a value needs to be provided for item 2, a value needs to be provided for item 3. But what if the first person is just buying only one item? Then we are going to have a problem over here. So somebody can say, okay, then let's set the default to all of them to 0, so that if somebody just selects one and we are just trying to find the sum, the total, it is going to be this plus 0 plus 0. This one makes sense, okay. But then somebody can purchase 1,000. You can never think of how much somebody is going to purchase. So we cannot, this is not sustainable trying to do it this way, okay. And that's the point we have over here. So over here we can use this special initializer list over here. Now what this initializer list does is, okay, it gives us the opportunity to pass in a number of arguments, okay. Maybe a little bit unlimited, okay, in some way. So over here we see that, okay, in order to use it we need to include it, because this is more or less like a standalone library, just as we are using iostream. So we say include initializer underscore list over here, and then we have initializer list. We specify that this is an int, okay, it can be a float, and then we pass in numbers over here. This is just a variable name, so this is like the container. So let me just show you. So over here I'll just come in here and I'll say include, then inside of this I'm going to say initializer list, as we have over here. Then instead of doing it this way, I'll just do initializer list this way, okay. Then in here you could clearly see that I need to pass in the type of data type, okay. So over here I'm going to say, okay, this is going to contain some floats, and then let me just call this items. So this one makes it a little bit flexible in a sense that, well, if it is one item it works, if it is 2 it works, if it is 100, if it is 1,000, if it is 1,000,000 items it works. All right, because of the initializer list we have over here. So this is a variable or the container we are going to work with, and with this container we can, let me just clear this. With this container we can have some interesting things to see. Let me just clear this. So in here we are actually going to use a loop, okay. Remember what we dealt with loops. So what I have over here is, okay, so with loops there's a list, okay, more or less a list. But then in C++ we usually don't say list, we prefer to say array and stuff like that. But then there's a list, and a list is basically going to contain more than one thing, okay. So normally you would want to have it this way. You would want to have it this way. So for instance, the list is going to contain maybe 20, 30, whatever items that you want. Now we can loop through this, okay. Remember what the looping does. Now what I'm going to do is I'm going to declare a variable. So I'm going to say float total, and I'm going to set this to 0 initially. So float total is going to be equal to 0, and now I'm going to say for, then I'm going to loop through the items over here. But then there's a shortcut over here. I don't know if we discussed this in class, okay. So over here I'm going to say for whatever inside of the list, okay. So for the number, this more or less like inside of the list, then we do some few things over there. So I'm going to say for the item inside of the items list, what do I want to do? Okay, I would want to be adding them. So how do I add them? I want to do, okay, the total that I have over here, okay. Let me just cross check Okay, so the total plus is equal to the item that I have in there. And finally, I would want to, for instance, maybe return the total outside of that loop. Okay, so upon the first iteration, total is going to be 0. Then based on the numbers we provide, so let me just call this shopping cart list, function over here. So I'm going to call this shopping cart function, and then I'll need to provide the list of things that was provided. So the system will be designed in such a way that whenever an item is clicked, add to cart, that value or that price of the item will be sent over here. So let's say the first one is 10, the second one is 40, the third one is 50. So at the end of the day, based on what we know, okay, simple calculation, this is 50 plus 50, so we expect to see 100 over here. But remember, we are returning. So if I'm to do something like cout, okay, and I'm going to do something like this. I'm going to say total is going to be equal to whatever thing I have over here. And let me just add something over here like no, let me just end line this way, and let me just do Ghana cedis this way. Okay, so I hope this one works. So now when I run this, we have a few things over here. It says it was expecting this, okay, but it had this online 13. Let me see. For the num inside of numbers plus is equal to num. Okay, let me just try and figure out what is happening over here. Okay, so it was expecting a number of these ones. Item is not declared. Okay, so I need to give it as you can see, there's a new variable item, so we need to give it a befitting how do you call it, data type. Okay, so this is going to be a float. So now let's run this and see. All right, so clearly you can see that the total is going to be equal to 100 Ghana cedis over here. And let's say if somebody comes the next day, this is just 3 items, but then somebody is adding more. So there's 700 over here, there's 100 over here. So this is going to be 100 plus 700, which is 800, plus another 100, which is going to be 900. So this one comes in, and then we didn't have to change the code, but it is dynamic. And it is dynamic in a sense that we are using the initializer list over here. Okay, so this one has the laxity to accept 1, 2, 300 or even 1,000 arguments over here without necessarily coming back to come and change the code. So this one looks interesting. All right, so this is going to be the end of functions over here. There are some few things over here, but then don't worry so much about them when it comes to functions, but then you can practice them. Okay, you can practice them. Now these are things I want you to practice. Now write a function to find the largest of 2 numbers. So you just check if this is greater than this, then this one is big, something like that. Okay, so this is very simple. Now write a function to check if a number is odd or even. This one, I think we did it when we were just typing the code, but now just package it in a function. All right, now the next thing we are going to look at is object-oriented programming. So I'm going to end this chapter, and then I'll make another video where we are going to discuss object-oriented programming. All right, thank you very much.